I'm doing some scope measurements on this ultrasonic sensing evaluation board, and I need 3 channels to do that, and unfortunately my oscilloscope only has 2 channels. Still, I was able to resolve this, and I'll explain you here how I did that. Now, as you can see in the user guide of the evaluation board, we would need 3 input signals in our oscilloscope. One to measure and trigger on the start signal, one to measure the stop signal, and one to view or visualize the piezo signal. And my oscilloscope only has 2 signals, so I have to find something, and for that my external trigger and my memory or reference function of the oscilloscope come to the rescue. The signal that we want to see on the screen is the start pulse here, the moment that the driver is going to excite the piezo sensor. We want to see the stop signal, and we want to measure the difference between the start and the stop here, and we also want to see what analog signal is going to the piezo sensor and what is coming back. So I'm going to visualize those 3 signals on a 2-channel scope. Hang on. You can see here on my oscilloscope that I have the 3 channels. I have the start channel, I have the stop channel, and I have the analog sensor channel. This is where the piezo element gets excited, and this is where the echo returns. Now you can see that I have 3 inputs here on my oscilloscope. We have the A and B channel. The A channel is showing the analog data to the sensor and back, and the B channel is showing the stop signal, and the external trigger is going to the start. So, but you also see that I have the external trigger shown here, and that's the reference function of my oscilloscope that I used here. So before making this picture, I first connected the A signal to the start. I recorded that data with the reference button here, and then I moved it up so that it's out of the way. From that moment on, I could disconnect the A signal because the scope is triggering on the external signal anyway, so that's the same signal as this one, this rising edge. And then I could reconnect my oscilloscope's A channel to that analog signal coming to and from the sensor. And you can see that the signals that we are seeing here are quite identical to the signals that we're seeing on the user guide. And the reason why this is now not standing stable is because I've just touched the table and the thing is going berserk because my water level is shaking. Okay, let's now try to repeat this setup so that I can show you how I did this with only 2 channels and how I put that first start trigger into memory. So I'll first reconnect the A probe to the start of my evaluation board. As you can see, I have connected both the external trigger and the A channel of my oscilloscope to the start signal of the evaluation board. You can see on the scope that that start signal is captured here, the yellow line. I'm going to put that yellow line in the reference of my oscilloscope so that we can save it and keep it shown on the screen. I press the reference button, I save it internal, so I press the save button now. Now I should be able to move it up here out of the way. I can start the scope, and you can see that even though the A signal here is still changing, the reference is fixed. We can now remove that A signal and connect it to the output of our board. Voila, I've done that. The A signal is now connected to the composite signal from the piezo element, and you can see that the memory stays where it is, and that's actually the trigger point, and we can see that analog signal. So everything that we wanted is done. We have 3 signals on a single scope. It only works if that signal is repetitive and stays on a fixed position, and that was the case here. We're always triggering on that start pulse, and the start pulse has a fixed size, so this works perfectly in our situation. And now that we have those signals on our oscilloscope, we can use the cursor functionality to measure the time between the rising edge of the start signal and the rising edge of the stop signal, and that is an indication of how much water is in our container. So I'll first enable the cursor. We'll set it to manual mode. I'm not a real expert in using the remote software here, so that's always difficult for me. The A cursor has nicely put itself on the rising edge of the start signal, so that's okay. Now we have to put the B cursor on the rising edge of B. So now I have to push the B cursor to the right place. Not that easy with the remote software, but I'm going to do it anyways. Okay, we have it. So the first cursor is on the rising edge of the start signal. The second cursor is on the rising edge of the stop signal. And the delta that we have here is what we are looking for. So the delta of 42.2 microseconds is telling us the height of the water on top of the sensor. So that's it. We were able to measure what we wanted to measure, and in the meantime we were able to collect 3 signals on a 2-channel scope. So I hope that this little video helps you in your future endeavors.